Hello students, you are welcome to today's lesson. This is Core Mathematics SHS 2 and our topic for today is variation. By the end of this lesson, you will be able to define variation. You state the types of variation. Then you will be able to explain direct variation. And finally, you will be able to find the constant of variation. As we always say, mathematics is about real life. It is with us day in, day out. So we are looking at this variation. We will look at how it is. Somebody will ask, what is variation? Variation is the relationship between two or more variables such that when there is an increase in one variable, there is an increase in the other variable, and when there is a decrease in the one variable, there is a decrease in the other variable. Let's look at an example of variation in real life. We see, particularly in Ghana, whenever the cost of petroleum is increased, the cost of all commodities in the market also increases. We can also talk of savings at the bank with simple interest. Whenever your principal increases, the interest also increases. This is variation. Sometimes too, we have a variation in which when there is an increase in one variable, the other variable decreases. When we come to the types, we will look at that. Examples of the one which increases when the other one decreases is when we have more people weeding a piece of land. The time they will use, when the number of people increases, the time they will use in weeding will decrease, and vice versa. So that is about variation. I hope you've understood the explanation now. Now let's look at the types. We have four types. One is the direct variation, which is also known as direct proportion. We have the inverse or the indirect proportion, and then we have the joint variation, and finally we have the partial variation. So let's write the types. The first one is the direct or linear variation or proportion, as I've stated earlier. Number 2, so these are the types. 1, direct or linear variation or proportion. 2, indirect or inverse variation or proportion. Number 3, we have joint variation, and number 4, we have the partial variation. Partial variation. I know whenever you are asked to give the types, you will be able to give it as at now. At this stage, we will take them one after the other, and then we look at what each entails. So first, we will look at the direct or the linear variation or proportion. Direct variation. Direct variation. Direct variation is also the relationship between two variables. In this case, the emphasis is on two variables. The relationship between two variables such that an increase in one causes an increase in the other, and vice versa. Vice versa means the decrease in one causes a decrease in the other variable. As this one goes up, the other one also goes up. If this one comes down, the other one will also come down. That is direct variation or direct proportion. So you can write it down as you are learning. You can write it down. Direct variation and in two variables, the relationship between two variables, such that an increase in one causes an increase in the other, and a decrease in one causes a decrease in the other. This is also known as the linear variation or linear proportion. And as we've already said, or as we know, talking of linear, the graph, as we are talking of the linear, the graph of the direct variation is a linear graph. A linear graph. Sometimes you may be asked in the objective test, the graphs will be drawn for you to select the one which is direct variation. So you should know the graph of a direct variation is always a linear graph, and it is form. Don't forget the direct variation is also called the linear variation or linear proportion. Let's look at some real life examples on the direct variation. Like I stated earlier, that was general example I gave, but this one is on the direct or the linear variation. When you deposit money in your savings account, you know definitely you are going to get an interest. So the more you deposit, the more your principal, the more your interest. This is direct variation or direct proportion. When the cost of petroleum is reduced drastically, you know that items in the market will also be reduced. That is also an example of the direct variation or the direct proportion. Let's consider the table I have here. This table we have here is a simple interest calculated on some principles for a period of 1 year at the rate of 5% per annum. Whenever the principal is 100 cedis, the interest will be 5 cedis. When the principal is 1,000 cedis, we are going to get an interest of 50 cedis. 10,000 we are getting 500, and then 100,000 we have 5,000. So looking at this, we can see that the principal is directly proportional to the interest. Whenever the principal is increased, there is direct increase in the interest. So this is an example of the direct. And with this, we can write it mathematically as the principal varies directly as the interest. The principal varies directly as the interest. The principal varies directly as the interest. We can also use other statements to mean the same. In case of examination, you get some other statements. So let's add some of them. We can say the principal is linearly proportional to the interest. The principal is linearly proportional to the interest, which means the same as what we have here. Another statement that we can use is that the principal varies linearly as the interest. The principal varies linearly as the interest. So this statement can be used to describe the direct variation. Varies directly as linearly proportional to, and then varies linearly as. All these statements can be used to describe the direct or the linear variation. As we stated earlier, we are looking at the direct variation. These statements we've written here can be written mathematically, and we have a symbol that we use to represent variations. This symbol we have here, when you see it, this is variation or varies. So as we've stated, the principal varies directly as the interest. When we use P to represent the principal, and then we use I to represent the interest, then this can be written as P is directly proportional to interest. P is linearly proportional to interest. So this is how to write the statement mathematically. Let's look at another statement. Y is directly proportional to X. Y is directly proportional to X. Mathematically, this is written as I hope you understood. Now, if I give you one to write it mathematically, I know you will be able to write with ease. Now, try this and let's see. The area of a circle is directly proportional to the square of its radius. The area of a circle is directly proportional to the square of its radius. Try to write this mathematically or symbolically for us to see. You have 2 seconds to do that. I know the time is up, so let's see if you've done it correctly. Here we represent the area, which is a variable. We represent the area by a variable and the radius also by a variable. So let's use A to represent the area and R the radius. And that we are going to have A is directly proportional to the square of R, or R squared. So this is how to write it mathematically. I hope you are okay, and I know you got it right. Okay. Let's look at another example. The cost C of a piece of cloth is linearly proportional to the length of its side. Let's represent the length by L. Try this as well. Its side. Yes, the time is up. So let's see if you've written it nicely. The cost is C, and it is linearly proportional to the length L of its side. So this is how to write it mathematically or symbolically. We are moving on, and at this stage I want us to go back to the table I drew earlier. We are coming to talk about a very important thing in variation. We are coming to talk about an important thing in variation, which is called the constant of variation or constant of proportionality. Constant of variation or constant of variation. But remember, the principal and the interest, as we stated earlier, they are all in Ghana cedis. Let me put it here. Okay. Looking at the principal and the interest, let's look at something. Let's divide the first principal by its corresponding interest. Sorry, 100 divided by 5. This will give us what? You see, 20. Let's divide 1000 by 50. This is also equal to 20. The third one is 10,000 divided by 500. This is also equal to 20. And finally, from the table we have 100,000 divided by 5,000, and this is also equal to 20. So whenever we divided, we've seen that this 20 is constant throughout. So from here we can say that whenever we divide the principal by the interest, we are going to get 20, which is a constant value. In the same way, and mathematically, if we want to find the principal, then we can make P the subject here, and that will give us P this will give us P is equal to 20I. P is equal to 20I. This 20 is the constant of variation or the constant of proportionality. Conventionally, we use the letter K to represent the constant of variation. So in this case, assuming we don't know the constant as 20, then this statement we have here, we will have P is equal to Ki, where K is the constant of variation. So whenever you multiply the constant by the interest, you get the principal. You get the principal. Okay. So we are saying K is K is the constant of variation. K is the constant of variation. Let's go back a little bit. When we were writing the mathematical statement or the symbolic statement, for example, P is directly proportional to I. We had this symbol here. And when we are working mathematically, we can't work with this. So we have to introduce equal sign to help us solve for whatever variable we are looking for. And the moment we introduce that equal sign, this symbol is removed. And then we introduce the K, which is the constant of variation. So in this case, we are going to have P is equal to Ki. P is equal to Ki, where K is the constant of variation. It's very important. If you forget about the K, it means that all that you are doing will be wrong. So whenever you bring or you introduce your equal sign, don't forget to bring the constant of variation. Good. Now let's look at some examples on how to introduce our K. Let's look at some examples on how to introduce or write our K. I remember we looked at this example. The cost C of a piece of cloth is directly proportional to the length of its side. And we wrote this as the length we use L. So now let's write the statement mathematically. We have C is proportional to L. Now if we decide to solve for the cost or the length, because of this symbol we can't, and as we've stated earlier, we know variation has a variation constant. So we have to introduce the constant. So we write this as C is equal to KL, where K is the constant of variation. The constant of variation, or the constant of proportionality. Take note of that. We've written two examples here. The first one is the principal and the interest, and this is the cost and the length. So we will give you one to write for us to see, or for me to see if you've actually understood what we are looking at. y varies directly as x. Y varies directly as x. Write this symbolically, that is with the variation symbol, then you introduce your k. You have 1 minute to do that. Okay, let's see. Compare what you've written with what is on the board. We have y is directly proportional to x, and this will imply that y is equal to kx. Alright, students, gradually we are coming to the end of the lesson, and I want us to recap all that we've learned today. We started with the topic variation, and we said variation is the relationship between two variables, two or more variables, such that a change in one causes a change in the other variable or variables. We gave examples. I know you have the examples down. We also looked at the types, and we said we have 4 types. The first one being the direct or the linear. The second one, the indirect or the inverse. Number 3, we have the joint. And number 4, we have the partial variation. We took the direct variation and we discussed. We said that the direct variation involved 2 variables, only 2. So you can underline the 2 in your notes. The relationship between 2 variables such that an increase in one causes an increase in the other and vice versa. Or somebody will say, and a decrease in one causes a decrease in the other variable. That is direct variation. We also gave examples on the direct. Then we looked at how to write variation questions or direct variation questions mathematically and symbolically as well. We also looked at the constant of variation or the constant of proportionality. And we looked at how to introduce the K in our statement. Students, this will bring us to the end of the lesson. But as you are going, you can't go just like that, so you take some assignments and then you try as much as possible to answer them. So write the question. I'm writing the questions on the board. Write them down and then practice on them during your leisure time. Alright, students, you take these two assignments. Given that y varies directly as the square of x, write down this statement symbolically and introduce the k, that is the constant of variation. 2. If x is directly proportional to the root of y, write down the variation equation by introducing k, the constant of variation. Alright, students, this brings us to the end of today's lesson. Hope to see you in our subsequent lessons. Thank you for watching.
Thank you for coming.
How did it go?